This is Jack Jackson back with our second in our series of videos on circular trigonometric functions. So recall last time we generalized the definitions of sine, cosine, and tangent and the reciprocal functions, secant, cosecant, and cotangent, so that we can define them for inputs of any real number, or at least that's true for sine and cosine. The other ones had some places where they were undefined, but for the most part we could put in any kind of real number for the measure of our angle. So here are the general definitions. Let's review that. So if we place an angle in standard position, that is, vertex at the origin, initial side along the positive part of the x-axis, and we rotate an angle, however much we rotate, that's going to land at a certain point. We take the coordinates of that point, any point on the vertex of the terminal ray, take any point there besides the vertex, and it will have a coordinate x and y. We let r be the distance to the origin, so r is going to be the square root of x squared plus y squared by the Pythagorean theorem. And then we can define the six trigonometric functions as cosine of theta is x over r, sine of theta is y over r, tangent of theta is y over x, secant of theta is r over x, cosecant of theta is r over y, and cotangent of theta is x over y. So notice that secant is the reciprocal of cosine, cosecant is the reciprocal of sine, and cotangent is the reciprocal of tangent. So these are the general definitions. Of course, if we have the unit circle, as we have pictured here, then r is just 1, so these formulas simplify a bit. So the cosine of the angle is just x, the sine of the theta is just y, and tangent of theta is still y over x, cotangent of theta is still x over y, but the secant and cosecant formulas reduce a bit too, so secant of theta is 1 over x, and cosecant of theta is 1 over y. So those are the basic definitions, but notice we can do it with, not necessarily just with the unit circle, we can do it with any circle centered at the origin. Once we find any, or in other words, take any point on that terminal ray with coordinates x, y, just let r be the distance to the origin, and we can use these versions that you see right here. So if we look at this, and this shows the ratios here. Over here we have the general definitions given in terms of r, x, y, and r, and then we have the actual values of those functions as well. Now, one of the things I want to look at is, let's review a couple of things in terms of the sign of the trig functions. Now, unfortunately, we have the same pronunciation for sine, sine, the trig function, and sign, meaning positive or negative. So we have the sign. So right now I'm talking about the sign sign, positive or negative or 0, of each of the trig functions depending on where we are. So remember, when we're in the first quadrant, x, y, and r are all positive, so all of these functions are positive. Cosine, sine, tangent, secant, cosecant, and cotangent are positive. But what happens when we move into the second quadrant? Well, what about x and y there? Which are positive, which are negative? Now, r is the distance to the origin. Since it's a distance, it's always going to be positive. So we're going to always let r be positive. It's just a matter of x and y, whether they're positive or negative. And of course, if we're in the second quadrant, then we know that the x is negative and the y is positive. So remember, x is associated with cosine and secant. So cosine and secant are going to be negative, whereas sine and cosecant are going to be positive. Now notice in the second quadrant, one is negative and one is positive, namely x is negative and y is positive. So when we do the ratios, whichever one's on the top, tangent of theta or cotangent of theta, we're going to get they're both involving y over x or x over y, one positive, one negative, so those trig functions are negative there. If we go down here into the third quadrant, what do we have? We have x is negative and y is negative. So that makes both cosine and sine negative, And of course the reciprocals, secant and cosecant, are also negative. So all four of those are negative. But the two negatives cancel out for the x and y when you divide, so tangent of theta and cotangent are positive. What about in the fourth quadrant? That's over here. Here we have x is positive and y is negative. So since x is positive, that makes cosecant of the angle and secant of the angle positive. But y is negative, so sine and cosecant are negative. The signs are opposite there for x and y, so that makes both tangent and cotangent negative. So let's go one at a time. Let's think about cosine. Where is cosine positive? Cosine is positive anytime x is positive, so anywhere over here in quadrants 1, or on the x-axis over here on the positive part, or down here in the quadrant 4. So 4 and 1, these quadrants, x is positive, so cosine and secant are positive. Whereas if we're over here in quadrant 2 or 4, or 2 or 3, excuse me, 2 or 3, like this one, or right on the negative part of the x-axis, all of these have a negative x, so that makes cosine negative. If you're right on the y-axis, we get an x of 0, so if you're pointing straight up, for example, pi over 2, or straight down, for example, 3 pi over 2, or negative pi over 2, those angles have x is 0, so cosine is 0, and secant then is actually undefined. Okay, let's consider sine next. Sine is essentially the y value, or y divided by r, and so here we have, up here, the y's are positive, so that's first and second quadrant. So sine is always positive for a first or second quadrant angle, including one. Also, this is neither first or second quadrant, it's straight up, pi over 2. Sine is going to be positive there as well. In fact, it'll be 1 there. Okay, but that's positive for y here. If you're down here in the third or fourth quadrant, third quadrant or fourth quadrant, these down here give us values that are negative y values. Below the terminal side is below the x-axis. And so anything down here is going to have a negative y, and that negative y is going to make sine negative, and of course cosecant negative. If the y is 0, for example, an angle of pi, or angle of 0, or angle, if you rotate around, 2 pi, or minus pi, if we rotate that way. But if anyway, as long as that terminal side ends up on the x-axis, either pointing to the right or to the left, then we get a y of 0, and so this tangent is 0, and cotangent would be undefined. Now, what about, I meant to say sine is 0, and cosecant is undefined. Okay? It is also true that tangent is 0 here, and here, because we have a y of 0 and an x not 0. So let's look at tangent for a minute. Tangent is going to be positive when the signs of x and y are the same. So that happens in the first quadrant and in the third quadrant down here. So the third quadrant and the first quadrant are going to have tangent and cotangent positive. If the signs are different, like x positive, y negative, that would be fourth quadrant, or x negative, y positive, that would be second quadrant. So second quadrant or fourth quadrant, signs on x and y are opposite, so that's going to make tangent and cotangent negative. Notice if, so let's talk about what happens right on the axes. So what happens if you're pointing right out here? Well, we can do everything from the unit circle here. The x is 1, the y is 0, and the r is 1. And we can see what that works out to be here. So x is 1, says the cosine of 0 is 1. So that the secant of 0 is also 1. The sine of 0 is 0. The cosecant is undefined. Cosecant of 0 is undefined. The tangent of 0 is 0, and the cotangent is undefined because we have a y of 0. Okay, what happens if we have... Now that's also, I said that for 0, but that's also true if the angle is 2 pi, or 4 pi, or or do around another time. Let's see, go around once, it's 2 pi. Go around twice, it's 4 pi. Go around once this way, it's negative 2 pi. Go around twice, it's negative 4 pi. Or you could go negative 2, 4, 6 pi. Either way, as long as you end right up on the x-axis, this point is going to end up ultimately at the point 1, 0, and then r is 1, and so we can use that to figure out what we did. Now, if you end here, for example, if you go a rotation of pi over 2 radians, or 90 degrees, then you're going to end up at right on the y-axis. Okay, and if we do that, what happens? Well, the x, what are the coordinates of that point? Well, the coordinates of that point are 0, 1. So x is 0, y is 1, and r is 1. And so we can use that here. So x is 0, so cosine of pi over 2 is 0. Sine of pi over 2 is 1. Secant would be undefined for pi over 2, but cosecant would be 1. Tangent of pi over 2, let's see, y is 1, but x is 0. We're dividing by 0, so tangent would be undefined there for pi over 2. But cotangent is defined. It's 0. 0 over 1 is 0. And again, that's not just for pi over 2, but for maybe minus 2, 1, 2, 3 pi over 2, or 2 pi plus pi over 2. That would be 1, 2, 3, 4, 5 pi over 2 would be there. If we rotate around like this, let me do it again. 1, 2, 3, 4, 5 pi over 2s. So that'd be 5 pi over 2. Okay, what about if we end up here on the negative part of the x-axis? What would that be? See if you can figure out what they would all be. Okay, well, the cosine, let's see, x is, what are the coordinates? X is negative 1, y is 0, r is 1. So use those and just use these formulas. So the cosine of, say, pi, which would be one way to get here, or the way it's marked here, it would be negative pi for the angle. And what would that be? Let's see, that's the cosine would be x over r. R is 1, x is negative 1. So this would be negative 1 for cosine, and that make negative 1 for secant. Sine is the y, which is 0, which means cosecant's undefined. Cotangent's also undefined, because both of those we're dividing by y, which is 0. And tangent is 0 divided by negative 1, which is 0, so tangent of pi is 0. Alright, so do one more. What if we land going here? No matter how many times we rotate, no matter which direction we rotate, it only depends on where it ends up for the trig functions. So, what do you get for the trig functions there if the angle is, for example, minus pi over 2? Or if we rotate, if we rotate this way, it's minus pi over 2. If we rotate this way, it's 1, 2, 3 pi over 2. The way it's marked here with the pink arc, it's actually minus pi over 2. So, in any event, what is that? What are the trig functions of that? See if you can figure that out. Press pause if you need to, and then come back. Well, we see that we just need to find the coordinates of that point. We can do everything from there, and the coordinates are pretty easy. It's just 0 for x, negative 1 for y, and r is 1. So 0 for x makes cosine 0, and it makes negative 1 for y, makes sine negative 1. Cosecant is negative 1 then. Tangent is, we're dividing by x. X is 0. So tangent and secant are both undefined. And then we have 0 over negative 1 makes cotangent 0. So notice there are some times when tangent, cotangent, cosecant, or secant could be undefined. Tangent and secant are undefined when x is 0, either when it's pointing straight up or straight down along the y-axis. And the other two are that when y is 0, cosecant and cotangent are undefined because you're dividing by 0, and that's going to happen when the terminal side is pointing straight to the right or straight to the left when it's on the x-axis. So when it hits one of those, I'll call those axial angles, then one or more, well, two of the trig functions are going to be undefined, and the other four will be defined. But notice that cosine and sine are defined no matter what. Okay, so let's hide the general definitions, and let's review our sine SIGNs. Okay, so if it's in the first quadrant like this, notice that x and y are positive, so everything is positive. Cosine, secant, sine, cosecant, tangent, and cotangent are all positive. None of the trig functions is negative. If you're in quadrant 2, y is positive, so that makes sine and cosecant positive, but negative for x, so that makes cosine, secant, tangent, and cotangent negative. If you're in quadrant 3, down here, we see that, well, nothing's positive for x or y. Of course, r is always positive. So that means but the signs are opposite on that. Both x and y are negative, so when they divide, they cancel. So both tangent and cotangent are positive. Negative for x and y, so cosine, secant, sine, and cosecant are all negative. And if you're in the fourth quadrant, x is positive, which makes cosine and secant positive. Y is negative, which makes sine, cosecant, tangent, and cotangent negative. So there's a nice summary of the signs, SIGNs, of the positive negative signs of the trig functions. We will do some more with working with the definitions of trig functions in our next video.